Hello everyone. In this problem, we are given a list of integers nums, and we need to return an array where the ith value in the array is the product of all the numbers in nums except the ith number in nums. Some constraints of the problem are you can't use the division operator in the solution, and all products will be less than the integer overflow value, meaning you won't have to worry about any value in the array overflowing. Something to point out is that for the purposes of this problem, we will not consider the array returned to be extra space. So for this particular example, we would return this array. You can see how -12 is the product of all the numbers except the 4. So 2 times -1 times 2 times 3. -24 is the product of 4 times -1 times 2 times 3. 48 is the product of 4, 2, 2, and 3, and so on and so forth. Now that you hopefully understand the problem, let's come up with a solution. The first solution is brute force. For every number, we iterate through the numbers to the left and right of that number and multiply them together. For the time and space of this solution, if we let n be the amount of numbers in nums, then the time is O of n squared, 1n for the outer and 1 for the inner for loop. For space, nothing is being used, so that is constant. Okay, that's it for the initial solution. Let's try and improve it further. So to improve, let's look at what might be a repetitive process in the initial solution. The repetitive process is in the J loop, where we repeatedly multiply numbers that for the most part have already been multiplied together in the previous I for loops. So to avoid and improve upon this, we can pre-compute the products on the left and right side for each number position. So in this example here, for every number in nums, let's pick this -1. You can see how the left value for it, 8, represents the products of 4 and 2, which are the numbers to the left of the -1. On the right side, you can see how 6 is the product of 2 and 3, which are the numbers to the right of the -1. As another example, if we look at this 2, the -8 is the product of 4, 2, and -1, which are the numbers to the left of the 2, and the 3 is to the right of the 2. To code the solution, first we start with our products array, which is our final answer, and we also initialize our left products and right products array, which will hold the pre-computed values. Next, we pre-compute the values, first for the left ones. We will leave the 0th position with the sentinel value of 1, but we start iterating from the index 1 position. The left product of this position is equivalent to the product of one position to the left times the num I-1 value. Remember, we are doing I-1 and not I because this array represents the products of all the numbers to the left, but excluding, not including this position. For the right ones, it's the same idea. We start with the second to last index number and assign the ith right product value to nums of I plus 1 times the right product to the right. And finally, for the answer, we just need one more pass, and these are equal to the left pre-computed values times the right pre-computed values. For the time complexity of this solution, we make 3n passes, but no nested looping, so this is 3n, which reduces to n. We do make a trade-off with space though. We store extra space of n, each for the left and right pre-computed values. Okay, that's it for the second solution. In the final solution, we're going to try and improve the space complexity by getting rid of the space used by the pre-computed values. Again, looking back at solution 2, we can make the realization that there is no need to use extra arrays to store the pre-computed values. We can just reuse the answer array, which, as I said earlier in the problem, doesn't count as extra space, as it needs to be created to be returned as the answer. So our approach will be to compute all the left side products first in the answer array, then compute the right side products and multiply those by the already computed left side products in the array. Here's the code. We have a left product, which is just a number this time. It starts with the value of the first number in nums. For every num starting with index 1, we assign the left product into the answer array for the ith position. Then we multiply the left product by nums of I to compute the value for the next position. Now that all the left products have been computed, we do a similar thing for the right products. Starting with the rightmost value of nums, iterating from right to left, we multiply the existing left product value at the ith position by the right product to get the final answer in the ith product. And then we update the right product by multiplying it by the ith nums value. For time and space, our time remains at O of n, and we just make 2 linear passes. For space, this algorithm improves from the previous one to O of 1 because it doesn't use any arrays except the answer array. And as I stated earlier, that isn't going to count as extra space. Okay, that's it for this problem. We went over 3 solutions, from brute force to the most efficient linear time and constant space. Hope this video helps. Thanks for watching and good luck on all your interviews.